In a previous video, I claimed that a quadratic equation, which is what we have here, could be transformed into the quadratic formula. In other words, any quadratic equation like we have here is equivalent to the quadratic formula that we have here. So I'm going to walk through a proof of that in this video. I'm just going to convert this generic quadratic equation here into the quadratic formula. Now the first thing that I'm going to do is I'm going to copy my quadratic equation here so that I can start to manipulate it so that we can turn it into the quadratic formula here. Okay, so I have my quadratic equation copied over here, and the first thing that I'm going to do is I'm going to divide out the a coefficient here so I can start to get it into this form that I have on the left-hand side down here in yellow. So I divide all of my terms by a. And ax squared divided by a is equal to x squared, and then plus b over a times x, plus c over a, and 0 divided by a is equal to 0, so I'm left with 0 on the right-hand side. The next thing that I want to do is I want to move this term over to the right-hand side, and I'll explain why in just a moment. So I subtract ca from both sides, and that gives me x squared plus b over ax, and then I'm going to leave a blank spot here, and that's equal to c over a, so negative c over a. So the reason that I subtracted c over a from both sides and then left this blank spot here is because I'm trying to manipulate the left-hand side of this equation into this form that I have on the left-hand side here in yellow. Again, I'm doing that because if I can manipulate the left-hand side of this equation here to follow this form, then I can replace the left-hand side of this equation in purple with this perfect square where I have the sum of two terms squared. And so the next thing that I'm going to do here is I'm going to look at the coefficient in front of my x term here, that's b over a, and the term that I want to add here is the square of half of b over a. That's what I have here. 2y is twice, or I should say y is half of 2y, and then I take the square of that, and so that's exactly what I'm going to do here. So I'm going to add, and I'll put this below to show that it's an addition. I'm adding b over 2a squared to both sides. Of course, whatever I do on the left-hand side, I have to do on the right-hand side also. So I have b over 2a squared being added to both sides. So let's rewrite that. We have x squared plus b over a x plus b over 2a squared. And then on the right-hand side, I have these two terms, a negative c over a and a b over 2a squared, but I'm going to write this term first, and that will be clear. It'll be clear why I'm doing that in just a moment. And in the process of doing that, I'm also going to multiply this out. So b over 2a squared is equal to b squared over, let's see, 2a squared is 4a squared. 4a squared, and then I can't forget this, subtract c over a. Okay, so on the left-hand side, I have something that is equivalent to what I have in yellow on the left-hand side here, and so I can replace what we have here in purple with what I have on the right-hand side of this equation in yellow. And instead of my two terms being x and y, my two terms are x and b over 2a. So let me write that out. So that will be x plus b over 2a, and all of that squared. Again, I can replace this part on the left-hand side in purple. I can replace that with this squared term, or sorry, I can replace that with what I have down here in purple because of this relationship here where you have the factor of a perfect square. So now that I've replaced the left-hand side of this equation, I can copy down the right-hand side. But before I copy it down, I want to find a common denominator for these two terms so that I can combine them. So if I multiply this term on the right, c over a, if I multiply it by 4 over a over 4 over a, it's not going to change the value of this because 4 over a divided by 4 over a is equal to 1. So it's equivalent to multiplying it by 1, but it will give me a common denominator of 4a squared. And so we have b squared, subtract this 4 times a times c, 4ac, and then the common denominator I have is 4a squared because I have 4a times a and 4a times a, or 4a squared, and so I have my common denominator of 4a squared. And you may notice here that I'm starting to approach the quadratic formula here. I have this part b squared minus 4ac, b squared minus 4ac. That's also known as the discriminant. We're part of the way there, and so let's continue. The next thing that I want to do is I want to take the square root of both sides of this equation. And so let me copy this down so this is clear what we're doing step by step. So I'm going to copy this down to the next level, move it down, and now I'm going to, like I said, take the square root of both sides of this equation. And that will, remember the square root operator and squaring are opposite operations. And so on the left-hand side, I'll just be left with x plus b over 2a. And then on the right-hand side, I'm going to leave the square root sign on the top, and then, well, let me write that out and walk through it. So I'm going to have this white arrow here to show the next step. So as I said, x plus b over 2a squared. The square root of that is x plus b over 2a. So I have x plus b over 2a. And that is equal to, on the right-hand side, I can think of this square root operator as applying individually to the numerator and the denominator. And so let me write it out like that. I have the square root of b squared minus 4ac, b squared minus 4ac, and on the bottom I have the square root of 4a squared, which is 2a. And I can't forget that this is plus or minus because we took the square root here, so this could be positive, or this entire factor could be positive or negative, or I should say entire term could be positive or negative. And to explain taking the square root of 4a squared, let me just show that in yellow. If we have 2a times 2a, that's the same as 2 times 2 times a, and 2 times 2 is 4, and a times a is a squared. And so the square root of 4a squared, as I said, is just equal to 2a. And so now we're almost done here. All we need to do is move this term on the left-hand side, b over 2a, over to the right-hand side. And of course, the way we do that is by subtracting that term from the left-hand side. So if we subtract b over 2a from both sides of the equation, then we will be done. And in fact, I will write it in red because this is the final form of this equation. We have x is equal to negative b over 2a is equal to, let me write it out this way, negative b, and then we already have our denominator down here, negative b over 2a plus or minus the square root of b squared minus 4ac. That is how we convert a quadratic equation in this form into the quadratic formula. We just take it step by step and use algebra, and this illustrates that these two equations are equivalent equations. Remember, this is why I had the equivalence operator between these two equations, because they're equivalent. They're just manipulated forms of one another.